I think there's a tendency for when things are really intense and services are offline, in the case of someone like Facebook, I mean, you are losing many millions of dollars, certainly an hour, maybe a minute is a huge panic situation where it's like, I've got to get this thing back online. And it's actually better to pause and figure out what's wrong, because those kinds of under the gun decisions, you end up deleting something or making a bad situation worse.
Welcome to SaaS That App, Building B2B Web Applications, the podcast where we share real-world stories, practical advice, and tech insights for those building or thinking about starting a tech-enabled business. I am your co-host, Aaron Marchbanks.
And I'm Justin Edwards. Each week we bring you the stories, strategies, and insights you need to build your SaaS or tech-enabled business smarter, not harder. Let's dive right in.
Hello and welcome back to SaaS That App. Something a little bit different for you today. We had a catastrophe last week in the land of AWS, and the three of us here thought we might jump on and give it a whirl on a little talk through about what happened and why it's important and things to think about. So joining me as always, my co-host, co-pilot, guy in charge, Justin Edwards. Good to see you, my friend.
Hey, good to see you too. Sorry for the temporary digs, but my life continues in chaos for the moment.
That's all right. I'm happy to be the anchor here. And we have joining us again, of course, Daniel Cannon. Daniel's going to be bringing a lot of tech insight here as well. Daniel, good to see you, my friend.
Hey, how's it going? I'm also coming to you from the land of chaos, as you can probably tell by my fabulous Airbnb decor behind me. So
that's right. It's the perfect time to do a podcast during
perfect
chaos.
Time to do a podcast. Absolutely. I think we're going to be talking about this a little bit on the next one. The joys of remodeling your house and squatting in the Airbnbs while it's going on.
I like your new background. It's got this real kind of air of like piety and like,
right.
Yeah. Are you finding your center? All right, gang. Well, let's just kind of jump right in. Probably most everybody that's listening is at least aware of what happened with AWS last week and the major outage that was occurring. And so here to kind of set the stage and shed some light and kind of dive us into this topic a little bit, Mr. Justin Edwards is going to set the stage and set the foundation, and we're going to get into some of the ins and outs of the specifics of what happened, but then also lessons learned, things to be looking to as you are building out your SaaS, you're structuring things for scaling and those sorts of things, and then also how to come back at the end and kind of recap, what happened. AWS is very good about this. They typically have these post-event releases that they talk about what happened, why it happened, what they did, how they're doing it better the next time. And it's just a good general practice. So Justin, tee us up, man.
Yeah, absolutely. So for folks who work on the internet, last week, every single site and every service that we use basically went down. I mean, every major big company was offline, which is kind of crazy. And they all went offline at the same time. And there's a reason for that. One of them is that AWS is the world's largest cloud, and many services that you know and love are entirely in AWS. The other piece of that is there is a very old, very large region in AWS called US East 1. So in AWS, we have they're called regions, and it's a collection of data centers around the country, around the world, and they're kind of aligned geographically with different places. And so US East 1 is really old, and it's the biggest, and so almost everything is in it. So fortunately, we deploy all of our stuff to US West 2, so our customers didn't have any downtime while this was going on. But Netflix and Spotify and other companies you may have heard of did have downtime, and is all related to this US East 1 issue. So I'll give you a little bit of the crux of what happened. The actual thing that caused the downtime is pretty boring, but the spillover at the post effects are more interesting. So essentially, there is a worker inside of Amazon's ecosystem that its job is to write DNS records, which is basically where we tell our applications how to get to a service. The particular service for this DNS record was DynamoDB, which is a document store. I'll save that rant for another time, but there's a document store database, and all the services in AWS in the US East 1 region depend on these workers to write these DNS records to be able to get to those services. What happened is they made a new version of the DNS rules, and they dispatched a worker, and the worker checked and made sure that it was supposed to overwrite these rules, and then it wrote off into the distance to do that, and it encountered a delay, and the rules didn't get written. Then what happened is the second worker got dispatched. It checked to make sure that it was supposed to do what it was supposed to do, and it wrote off in the distance, and it didn't encounter a delay. And that had the most up-to-date version of the DNS records. So worker 2 ran all the way there and wrote the records. And then worker 1, because the check happened before the delay and not as it should have happened immediately before writing the records, overwrote the proper records. And this doesn't happen very often. These kinds of jobs happen all the time. But this concurrency issue and the weird delay from worker 1 basically meant that worker 1 went in and trashed the DNS records, so no one in the entire region of US East 1 could get to this DynamoDB. And that's bad, but it's even worse than bad because a huge amount of the actual AWS services that power our applications rely on DynamoDB. EC2 instances, IAM credentials, I mean, just everything lives in DynamoDB for the actual AWS services. And thus the internet came crashing down. So the resolution for the actual issue was pretty quick. AWS got after it in a couple hours and that resolved. But the other issue is that there were several hours of downtime, which kind of built up. And one of the things that DynamoDB gets used for is batch and job processing. And so what happened is that all these jobs and workers and processes and things that needed to happen built up over the span of the hours of downtime. And then when the service came back, all these services cranked up to 100 and 120%, 150%, just trying to blast through this backlog of jobs and issues that got left behind. So that's why even though the initial kind of AWS resolution of the issue happened relatively quickly within a couple hours, there was fallout for a day related to job processing and all these kinds of issues.
So not exactly a cascading failure, just the one failure caused backup somewhere else, right? So perhaps more closely akin to a race condition sort of situation or something like that?
Yeah, so the initial issue was a race condition, which happened in the context of these cloud processes. So those kinds of things are easy to write and hard to track down. But then the fact that all these underlying services relied on the service that went down is the longer fallout, all the issues that persisted past the first couple hours were related to that, less some time for DNS to update and those kinds of things. So anyway, one issue is that it took it down for the entire region. So even people who were doing the right thing and deploying in a multiple availability zone, they still went down because the whole region was down. And so you had to actually have a multi-region deployment, which is not standard for most of us in the cloud deployment world. And yeah, it kind of serves as a reminder that the cloud's not magic. It's just someone else's computer. So there's data centers and servers and all these things. So yeah, that's the crux of the issue. And then all of us immediately spun into this frenzy of just like, oh, is this my fault? Is my application down or is it some other provider? And the answer in this case was it was this other provider. But a lot of people spent a lot of time, A, trying to figure out if it was their system that was down. And then B, we introduced a delay into a system that usually operates pretty well. And that exposes all sorts of other bugs of like, oh, well, our service is not robust to having 5,000 jobs queue up and then have to take them all on at the same time, like that kind of thing.
Right. So to be clear, the software itself, the different applications and the various companies and organizations that were affected, they weren't directly affected. It was more of an addressing. The service is still there. You just don't know how to get to it, or the systems don't know how to get to it, or just simply can't get to it. Right?
Yeah, no, that's exactly right. Where it basically, there's a big architecture and all these systems coordinate and come together, and you basically subtract out one of the pieces and take it offline. And now we see how the system has been designed appropriately to function with the service offline. How robust has it been programmed? But yeah, so that's kind of the issue. And it depends on how rigorous your software process is. But for our small business web applications, we don't consider the use case where the service is just offline sometimes. When you're Netflix or Spotify, you probably should. But our customers, for the most part, are not interested in paying for that kind of robustness. So there's also always a trade-off with being that robust. You're always giving something up as well, right? So.
Right. Absolutely. So getting into the result set, and Amazon, of course, took care of their portion of it. The fallout was all of the catch-up that was happening after the fact. Once we get through everything, we're to the other side. Amazon releases their statement. Everybody's kind of figured out what the issue is and have worked through their processes. Take us through a little bit about what other pieces of this that it exposed for AWS, Justin, because it was, of course, the DNS issue that was the impetus for the problem. But as you said, it starts to highlight other cracks or other faults or other things. They could be edge cases. They could be actually very specific use cases. How do they, or how have they so far gone about combating some of those other things that have come to light because of this particular issue?
Yeah, Daniel and I could probably riff on this a little bit, but there's kind of like a hardening process that you go through when you have an incident like this or you have downtime. So obviously fixing the immediate cause is where you start. So these workers need to be robust to one of them might experience a delay at some point. And then you just kind of move down into the downstream effects. So like for the issue where all these jobs built up and all these services went crazy trying to catch up and process them, maybe we need to build some kind of like slow acceleration, or here's a system where something introduced a delay into the system. Do we go tweak all these other services to make them be able to accommodate the delay? When we've had clients who've had downtime, which doesn't happen all that often, the immediate thing that we want to do is we want to understand what's going on. And we actually try to figure out what's going on before we try to get to a resolution. So I think there's a tendency for when things are really intense and services are offline, in the case of someone like Facebook, I mean, you are losing many millions of dollars, certainly an hour, maybe a minute, is a huge panic situation where it's like, I've got to get this thing back online. And it's actually better to pause and figure out what's wrong, because those kinds of under the gun decisions, you end up deleting something or making a bad situation worse. So that happens kind of at the same time. There's like a communication piece that happens. So you should reach out to your customers and let them know that, hey, we're something's not right. even though it's difficult and challenging, you try to have like calmer heads prevail, basically, of just trying to like stay calm, be methodical, go through your debugging steps and try to figure out what the issue is. After you kind of arrive at that, you can let everyone know what the issue is, and then you move into phase 2, which is finding a fix for it that is going to be robust and get everyone back online. I don't know the inner workings of AWS. Presumably they did a pretty good job on this. This is kind of an obscure issue, and they got it back online in a couple hours. So fair play to them. I'm sure they're still doing retros and stuff on this to figure out what else they need to change.
Well, like you pointed out at the top of the call, I mean, organization of that size and scale, and certainly even to the lesser extent, the services that rely on them, like the Netflixes and Facebooks of the world, I'm imagining that most of what they are dealing with whenever there are issues are edge cases. They're large enough, they're robust enough, they've been around for long enough, they've probably seen a lot of the issues that could potentially arise, and they've already got processes or things to address those in place. And then you run into one of these edge cases that maybe you miss or flies under the radar or just hasn't ever happened. And so you don't necessarily think about it occurring because it's a very low likelihood that it's going to occur, but then it happens. And so then you have to deal with it. And Daniel, I'm going to throw this over to you. I want to pick your project manager brain a little bit. When we're talking to clients in general about projects, whether it's hosting related or actual software development related, there's always a tipping point. I mean, there's always a give. It's like, we can harden this, or we can make this effective, or we can make this good for, pick a number, 80%, 85%, 90% of your users. We're going to stay on time. We're going to stay on budget. It's going to take care of this. And then though, what do you want to do with that last 10%? Is this something that we're going to plan for, roadmap for? Is it going to be something that we're just going to deal with organically? If or when it ever arises, we'll deal with the use case at that point. So how do you advise clients? How do you talk to clients about, maybe not AWS specifically, but in general, dealing with the largest set of potential issues versus these edge cases that could pop up or that maybe aren't even foreseen?
Sure. Yeah. I mean, in the context of the AWS thing, I mean, I don't know how I would advise somebody to do something different there as a client. I'm like, yeah, AWS is a very solid hosting provider. If you're looking for uptime, they make a 5 nines guarantee. So that's 99.999% uptime. That's pretty darn good. It's pretty hard to beat.
No doubt.
And they do have outages, and it always actually gives me a little bit of schadenfreude, I suppose, to be like, oh, a company like Amazon can't even keep their servers online. And it's like, well, our little customers and our little consulting company, we do a pretty good job keeping things online and not introducing bugs like this. But when you see something like this from Amazon, it's kind of a little bit of a nice reminder that even the smartest guys in the room can't solve this problem necessarily. So I think talking about uptime for someone like Amazon, I think there are always kind of trade-offs with every single one of these issues. Are you optimizing for robustness? Are you optimizing for speed? Are you optimizing for cost? And there's always trade-offs. Amazon makes these trade-offs, and we make these decisions between trade-offs too. And there could be an argument if uptime is your number one thing, you can go buy your own data center and have a whole dedicated team working around the clock to keep it online. Or if you want a cheaper solution, you can go with Amazon and have them hosted for you. And obviously there's a lot of benefit to it. So that was my rambling response to your question, Aaron. How did I do?
Yeah, no, that's fine. The point is, everything that we do, I mean, especially at our level, is heavily reliant on these foundational services and organizations. I mean, like you said, you could have your own dedicated cluster. I mean, people used to do that all the time. They would co-load their own box, their own actual hardware somewhere. But even that co-lo setup requires that wherever you have a co-load, be secure, be stable in their environments. You want to take the box and put it in a closet. I kid you not, we have had clients who literally ran their infrastructure off of a desktop machine that was in a closet.
Yeah, absolutely.
Sure, you can do that, but all you're doing is just pulling that thing in closer and closer to something that is less and less stable and less secure or certain. So at a certain point, you got to bite the bullet. Are you going to scale? Are you going to allow this to be something that's outside of your office building? Where do you want to go? And that reliability and that uptime is important, but it's not the end all be all. And however many nines you want to put on there, it's not ever going to be zeros. You're not going to get 100. It doesn't exist. And Amazon shows us this, and so do the other services. But that many nines, that's a lot of stability and a lot of reliability.
Yeah, I mean, this is just a trade-off. And I think this, like all things, you just kind of approach this with a practical framework. So how big of a deal is it that we have some downtime? People can't do their jobs logging calls with customers while the system is down. Yeah, that's disruptive, but people have paper, and I mean, we don't want to have downtime, but like, it's not a big deal. Whereas like the Facebook version, where it's like, oh yeah, we lose millions and millions of dollars every minute of downtime, a certain labor hour of downtime. Facebook should invest all the time and money and energy to never being down, because of how advertising works and how many continuous users they have. Like, That makes perfect sense. They should spend a lot of money to be robust. And Facebook has very little downtime. I mean, they had an incident a few years ago, famously, but it's a 20-year-old company and they've had hours of downtime in 20 years. It's pretty good. But I guarantee you it's because they pay a lot of money and their systems, their backup systems come online frequently. I promise you. Whereas for customers who are powering a little consulting firm or logging time or logging phone calls or whatever, it's like, well, if the system's down for a couple hours, it's disruptive to your day, but it's probably not worth $10,000 or $20,000 a year to make sure that we don't encounter that little bit of downtime.
I've talked to some clients, not just our own, but just people in general, projects and things along those lines, that the knee-jerk reaction for people who don't necessarily know the inner workings in some of this higher level architecture and how things are set up. Like you said, this was a particular region in AWS. If you explain it to the client, I have heard the reaction of, well, can we just copy over our application in a region that's not affected and then it'll work again? Dano, tell me about how you might approach that particular client or question.
There are definitely a lot of companies that actually have multi-region, multi-availability zone setups, and you can do that. That's the whole thing for sure. It's very expensive. It's very expensive to do. If you're not set up for it before the incident happens, it's pretty hard to deal with. I mean, if your database is unaffected, okay, maybe we can copy the application server over to a different region and then update the DNS to go and talk to that new region. I mean, there are ways that you can work around this, but it's very hard to do. It's much easier to do if you're set up for it in advance. And for some things that are super high criticality, super high volume applications, I mean, folks do set up deployments where they will have servers in US West, they'll have US East, they'll set stuff up in Google Cloud, they'll have their own on-prem stuff. I mean, you can build in multiple layers of redundancy. I think one thing, though, that is always worth bearing in mind is that if you're adding all of this redundancy and it all depends upon the same underlying piece of infrastructure, you don't actually really have that much redundancy. And you sort of think of it as this house of cards that's built up where you've got all of this stuff at the top that's super secure. But if you remove, or maybe Jenga, whatever, I don't know, you remove something from the bottom, the whole thing comes toppling down. And so, I think back, I don't know if you remember, this happened 10 years ago, but there was an issue in Texas. I won't remember the full thing that happened, but there was a heat wave. And because of the heat wave, everybody started running their air conditioning. Because everybody's running the air conditioning, it overwhelmed the power grid and it caused this whole cascade of failures. And we had all of these redundant systems in place, but they were all kind of correlated. The failures are all correlated and they all hit the same underlying infrastructure. And so, with the internet, you have DNS, for example, which is your routing, how you find the server. When you go to google.com, what server do I talk to? And if DNS goes down, that's it. That's the internet. The internet's gone. If you happen to know the IP address of the machine you want to talk to, okay, you can probably find your way around it, but your typical user is not going to have that experience. And it's going to cause cascades. It's going to cause cascading failures where everything in the entire internet just collapses. And that's actually not what happened here. It's not like we had DNS as a whole go down, but it is a huge vulnerability. And DNS is redundant. There's lots of DNS servers all distributed across the world. There's a lot of redundancy that's been built into that system as well. But pick whatever system you want. Power is an example. If you just lose power in the world, well, everything's gone. Now nothing works. So I think it's important when you're trying to build in redundancy, thinking about what are the correlated risks, what are the shared dependencies between these things, and are you actually adding redundancy by doing this, or are you just setting a lot of money on fire to feel like it's going to be more robust?
Yeah, I think that Daniel made a bunch of really good points there. But yeah, the reliance on single points of failure, if you take any system that still has a single point of failure in it and you don't have a lot of robustness, because as soon as that one thing goes down, the whole system goes down. And that's a little bit of what happened here. Or even for when we think about setting up high availability stuff for clients, and we do have customers with high availability setups, I don't typically have a failover key value store for Redis or whatever's being used for that. Or there are still these services where we're not robust to S3 being down. Our services are still going to fail if S3 stops working. And are we going to go through the process of setting up a second object file store and then have application logic to fail over to sticking stuff into Google instead of S3 and then having a true up process where we do all this? I mean, it depends how much money and what the criticality is. But I mean, the answer in our case has always been no so far.
So let's talk for just a second then about transparency and about communications. And again, it is no surprise. I mean, AWS is an industry leader here. I feel like they do an excellent job with communications, obviously recognizing what the issue is, but certainly initially recognizing that there was an issue and making sure that people who rely on those services, in as much as they can, are communicated with that there is this particular issue and that they are combating it. And then at various steps along the way, we have identified the issue. Here's what's going on. Okay, now we are combating the issue, and here's what we have done. Okay, the issue has reached resolution for our part, but now this race condition, in this particular case, these systems that have stacked up are now clearing themselves. Not really anything we can do about that at the moment because they just need to clear. So everybody just kind of hang on. I feel like that's very comforting to a client. I feel like it's very comforting to an organization to know that whoever is providing you with this service is aware, is doing what they can to make sure it's remedied, is communicating in a clear and effective way that this is what's happened, this is what we've done, this is how it's reached the resolution. And then at the very end, I also very much appreciate on the technical aspect that AWS releases these larger kind of post analyses. They're not always very lengthy. They don't often have to be, but it's kind of like a publicly available postmortem on these. And so that's great for them. And I think there's a lot that we could do to follow that lead. But I want to get both of your all's opinions on at what point do we, as people who are very far down this ladder, removed from AWS, but are of course reliant ultimately on some of their services, communicate to our clients who may not be aware and may not be in the loop of this level of technology and what has happened. They've just heard that the internet is down and nobody can get anything done. And holy cow, what's going on? How do we do that for our clients who aren't tuned into AWS land?
Yeah, I think communicating is very key with your customers, with your users. I think there's a real tendency, especially among startup founders, to try to sweep things under the rug and not own their failures, not own their outages. And I mean, especially in a case like this, where it's like, this is Amazon's fault. You can pass the bag, but for the most part, your users don't really want to hear blame or whose fault it is or anything like that. What they want to hear is, your data's fine. Nothing's been lost. That's all I always lead with that as number one. Like, there hasn't been any data corruption. There hasn't been a data breach. It's not ransomware. Like, don't worry about this. And then number two, we are working on a resolution. And if you can provide an estimate for like, this is when things are going to be online, here are the steps that we're taking. I think getting that communication out as soon as possible is very important. And I think doing the retrospective after the fact is also super helpful. Communicating back to folks, hey, we had an outage yesterday. Here's what's happened. Here are the steps that we proactively took. I mean, I think in that, you would probably acknowledge to your users that Amazon had this issue and that's why everything went down. And like, hey, by the way, half the internet was offline. It wasn't just us. You can include that in the messaging. But again, I would say, like, when you're talking to users, they don't really want to hear blame. They don't want to hear fault. They just want to hear that everything's okay, everything's handled. And here are the steps that we're taking to prevent this kind of thing from happening again in the future.
Yeah, we had a customer a while back who was moving on to our service, and the person they were hosting with previously had an incident where they were down for like 3 days. I mean, sites offline. This is an old data center, not a modern cloud. And all the messaging from the provider was like, our data center is down. And so someone in our data center messed up. So just can't really do anything because the data center is down. And it just wasn't good. The messaging was not well done. And they were actually right that it wasn't their fault, but the customer doesn't really care. Like, and it was in some sense their fault because they picked that data center and they worked with that provider. And I like the idea of just being transparent. And even if it's not necessarily your fault, owning the blame about it, just like, hey, our data partner is having a really big problem. And like, we selected them. We've been working with them for a long time. This outage is happening in their data center. And like, we haven't had this happen before, whatever. Pick your narrative. But I think it's better to be transparent than to come off as like some smug blame passing. All right, this time the whole internet's down. So who cares about your site? You think the people at Spotify aren't worried right now? Or, but you know, a lot of times you can pivot back like, well, look, I didn't pitch you on being a multi-cloud application because I didn't figure you want to pay more than double the hosting cost and pay me a boatload of money to set up your application to work in both ways. So we made this decision together kind of, and maybe I made it for you without telling you about it, but it's the right call for you. Getting back to that framework about how critical is downtime.
Yeah, and I think that speaks to trust too. I mean, the three of us certainly, and many people who are in the industry are consultants at the end of the day. And a very big part of being successful in that regard is, yes, being transparent, but also being trustworthy. And so for clients to be able to come to you and have this concern and have this care, and to Justin's point, be able to say, yes, we recognize that this is an issue. There are things that we decided during the course of building this application or this process that would not have done anything to mitigate this particular instance. However, there are things that we can now see that we couldn't before that might help going forward. Here are some ideas and the costs and timelines that are associated with it. You, business person, what do you want to do? Because we can absolutely do this and it will mitigate this particular instance and this circumstance or these use cases. but it may not necessarily catch this other stuff, and it would not have caught anything with this. How do you want to combat that? And so you build that trust with that partnership. You grow their business with them and help them understand what are the risks, where might I have cracks in my hardening or my infrastructure? What is it that can be done with my technology partners vis-a-vis us or whomever their consultants are to be able to address these? And I've always felt like that trust is just absolutely crucial. And it's so easy to let it go, as both of you have highlighted, just to simply pass the buck, because it's not a good day for us either, but it's not our fault. I think it's better to recognize the pain that may be involved with someone who's losing money every minute or every hour or every day that we're down, and help them to see that this has happened. Here are some things that we can do to take care of that.
A lot of times our customers just want to know what to tell their customers and what to tell their employees.
Exactly. And that's where that communication clarity really, it's like, we can suggest what to tell them. Phrase it how you'd like. Justin uses the term narrative. Build your own narrative around that, but here is what's going on. And we would advise letting your clients know that this is an issue, especially in this age of data security. If it's a security issue, it becomes very scary for a lot of reasons.
Yeah, I was just going to say, I mean, this is a conversation I've had to have with many clients over the years who have a security issue, maybe a minor one, not something where data was compromised, but where it's like there was an issue that went into production that could have potentially been exploited by an intruder. We don't have evidence of that happened. In fact, we even have logs indicating that nothing has happened, but this vulnerability was there. And I think most startups, their instinct is, oh, brush it under the rug. No harm, no foul. Let's move on. And my argument is always that actually builds trust with your users. If you step up and own that, send them that email and be like, hey, we had a security incident. And again, number one, your data's fine. Nothing's been compromised. Nothing bad has happened. If you can say that honestly, then say that. But I think stepping up and owning that and saying, hey, we had a security issue actually builds trust with people. It's like, wow, these guys, they had a security issue. They identified it on their own. They fixed it. They let us know about it. It makes me trust the company a lot more.
Yeah, I also think that this is kind of pivoting maybe a little bit into the retro, but I think the final communication on kind of when you sign off for the incident should explain your next steps for why this isn't going to happen again. So I guarantee to you that the little race condition for AWS has been resolved already, and they're not going to have an issue with that particular thing again. There will be another giant AWS outage. Don't know when. It's coming. Software goes down. It's just the nature of software, but it's not going to be from that probably.
For sure. So Justin, you want to put a bow on this for us?
Oh, sure. Yeah. So Daniel made this point too, but I think all the work that you could do up front before you have a downtime or security incident, the better. So war game this, figure out what your vulnerabilities are, think about likely causes of downtime. And this AWS one was a real weirdo issue. But especially for smaller applications that aren't dealing on this kind of scale, there are more common issues. So like war game those and figure out like what would we do if this service went offline, or what would we do if this downtime happens? And then you can do ahead of time to kind of set yourself up. And if we start doing this war game exercise and you realize that this is an absolute non-starter for business reasons, like that's a great time to get your high availability, your multi-cloud, get all that stuff set up then. So when this issue happens, you can laugh at the people who are just stuck on US East 1 and be like, oh, we're on 1 and 2, or we're on 1 and Google, or whatever. As you go through the incident, if you end up going through one, stay calm, get the information about what actually went wrong. Don't just throw a patch on it to fix it up because you're panicked that you're down. It's important to get that right, both for honesty and communication, and so you can actually learn from it. Because if you don't ever understand what the issue is and you rob yourself of the learning, you don't actually improve. Afterwards, I think you need to do a retrospective, figure out what went wrong, why it went wrong, identify any processes within your organization that led to this kind of issue becoming a thing, if that's applicable. If not, figure out why it's not going to happen again. And then, as we talked about the downstream effects a little bit, if these kinds of issues like jobs piling up are likely to, or retries getting crazy are likely to happen again, maybe you look into those other systems so that, you know, there's concentric circles of robustness and security. And so maybe you pick out that big outer one, but then maybe you identify two inner ones that you also want to be just a little protected against in the future. Yeah. And then communicate with your folks about the fact that you're doing your best and the downtime happens. And I think throw yourself under the bus where you deserve to be honest, forthright. And also, like, if you can give people the information they're looking for, especially like in our case where people just want to know what to tell their customers, write that for them or explain to them exactly what's going on so they can pass that on. That's what I got, Daniel. Did I miss anything you want to highlight?
I mean, I think the big takeaway is you just have to host everything in US West. I mean, come on, problem solved. Tupac, baby. No, I mean, I think the big takeaway for me on this is don't just walk away from this and pretend like it didn't happen and pretend like everything's be good in the future. Yeah, what Justin just said, Amazon will go down again. Or if it's not Amazon, something else will go down. And when a house burns down, they go and sift through the rubble to try to figure out what started the fire. They try to figure out how do we stop this from happening again in the future. You should be doing the same with your company, and you shouldn't even be saying, hey, pass the buck to Amazon. It's Amazon's fault. You should come up up with a plan. What happens when Amazon goes down? How do we respond to that? What are critical systems that simply can't go offline? What are ones that we're more okay with? And how much money are we willing to invest in this? How are we communicating with people when these things happen? And so on. So I would say, don't just move past this and say, hey, Amazon's fault, everything's good. Come up with a plan. We're doing that on our side for sure. We're learning a lot from this incident and figuring out how to bring that into practice in the future.
Fantastic. Guys, thanks so much. As always, it is a pleasure getting to talk to you guys, especially when we get to dig into some of the tech fun and things that are very present in our world that maybe not everybody realized can and will happen again. So, Justin, thank you, my good friend.
Thank you, Aaron.
And Daniel.
To anybody who's listening, if you went down because you were in US East 1, give us a call. We will be happy to stick you into US West 2. We have the technology. We can't do it.
You heard it here first. Well, they probably not first. All right. Well, thanks as always to our listeners. Really appreciate it. If you are so inclined, please give us a like or subscribe. Send us your comments, information that you might like to see on a future episode of the podcast. We thought this was a pretty timely one. I wanted to throw it your way. Again, thanks to my guest, Daniel, and thanks to my co-host, Justin. And we will see you all next time on SaaS That App.
Cheers.
Cheers.
Thanks for cruising along with us on SaaS That App. We hope you grabbed some insights that were inspiring, actionable, or at least entertaining.
If you enjoyed the show, don't forget to subscribe and leave a review.
Until next time, keep building, keep growing, and keep those apps sassy.